They can hear me, yeah? Or not yet? Oh, yeah. Perfect. 1, 2, 3. Oh, yeah. Everybody can hear me probably. Okay. Well, thank you for joining me. It's not very big numbers, but I heard that it's the end of the conference. So everybody's already leaving, probably flying or going home. So I am really thankful for you to be there and here to listen to me talking and rambling about 10x delivery. So who I am, I'm Alex. I'm from Berlin. I'm working at a company called Ride Capital. It's a startup in fintech space. And I'm also written the whole book on this topic. I was thinking about this topic for 7 years. And yeah, once it's crystallized last year, I decided to actually write it. It just spilled from me. So it was a lot of fun to do this. But besides that, let's start. Um, oh. All right. So agenda for today, we'll first talk about what is business value and what does it mean to even deliver at these different ratios like 0.1x, 1x, or 10x. I'll show you a couple of case studies where I've seen these different numbers, and I'm going to talk about how do you go to 10x, or how do you get closer to this from two different perspectives, from perspective of from scratch when you have a new company, or from perspective when you have an existing organization. And then I'm gonna give you a couple of insights on actual 10x software engineering delivery system as I designed it, and I'm gonna open for questions and answers. So, the first question, if I talk about business value, what even is that? Who wants to answer? So it's satisfaction and happiness. Okay, well, maybe, but what if there is something that is very valuable from business perspective, but actually does not make people satisfied, but still valuable, it's still beneficial? Do we have any other answers? Hmm? Maybe, yeah. So I think it depends on what you're trying to accomplish. So, for example, if you're a for-profit organization, that's probably correct. And for non-profit, there will be some kind of impact, some kind of benefit delivered. Yeah. Okay. I think that kind of sums it up. I have a little bit more sophisticated definition because in order to think in terms of measuring, we need to somehow quantify it, or we need to somehow make it more tangible and also more useful, because some of the measurements are not very useful. So I distinguish between actually three types of business value as a measure. So first one is expected business value. And this is a definition of business value that I found in Agile Ambition, so credit where it's due. They talk about business value is an indicator of the benefits expected to be gained by proposed change. So this is where we see customer satisfaction is because of some benefits that the customer got, or business profits because of some benefits that the business has obtained. And I can give you a simple example of such expected business value is we expect that the certain feature that we're looking at will save our operations team 30 minutes per day on average. All right. Why is it expected? Is because we don't actually know if it's gonna be true. Like, it's just our assumption that we believe that if we deliver this functionality, then it will save this amount of time. This is why there's a modifier of expected. Why did it do that? Okay, cool. There's second one is shipped expected business value, which is actually an indicator of when we had some kind of expected benefits and we ship them to productions to actual customers. So we perform the deployment and it's available feature now. For example, I continue in the story of this feature that saves time to operations team. The team has developed the functionality necessary and actually shipped this feature in production, and it is expected to save 30 minutes every day for the operations team. And finally, oh, I see. Sorry. That's what happens. Actualized business value is the final third metric where you have actually not just shipped, you've shipped and validated that the expected benefits have been gained or not, or have been gained partially. So in this example, we shipped the feature and we measured that operations team did not save 30 minutes per day. On average, they saved 20 minutes per day on average. So this is an actualized business value. And of course, there are different scenarios. There are scenarios where you have different discrepancies between expected business value and actualized business value. They can be complete opposite. Let's say we develop something, we shipped, and we actually are wasting more time to the people, and so on. So what business values should we even focus on when we talk about these three? Well, obviously, actualized business value would be the best indicator we can choose. However, with software engineering, it's very hard to control because we can only make assumptions about what actually going to happen. The second one would be the shipped expected business value. It's a relatively good indicator, and it is under our much better control because we can take action and do things to affect it. And the final one is expected is not really good indicator. We shouldn't focus on this because this one is easiest to control because you can just say whatever you want. You can say, I expect this thing to bring us millions, but if it's it could be just a fantasy. So and also additionally, you can talk about a lot of features and have a lot of expectations about them, but if you can't build them and ship them, then it also doesn't matter. So the shipped expected is sort of a good indicator to focus on. And in particular, it's also a lead measure to actualize business value. When I say lead measure, I mean that if we ship a lot of expected business value, then some of it will be transformed into actualized business value. And the more we are able to ship of expected business value, the more we'll have of an actualized one later. And of course, it's under our direct control, so that's nice. Now, next thing that I want to talk about when we want to measure or even think about how we can ship more business value or less, if that's your goal, we need to talk about types of work that we do in software engineering. Well, one type of work obviously is features, and some features can have expected business value, and some features may not have expected business value, right? So a question, who here ever worked on a feature where you didn't know whether it's actually valuable or not? Who worked here on features that you actually knew that there is no value? There's no customer, there's no business value, right? Some people, okay, so you know what I'm talking about. But okay, well, different question. Did you, who worked here on features where you knew, well, it's valuable and this is why? Okay, yeah, and how does it feel when you work on something that's valuable? Yeah, of course. Of course. Then there are another type of work, which is bug fixes, and these are interesting because bug fixes on their own, they do not, or they're not supposed to deliver extra business value, but they have sort of opposite effect. They are there to retain business value, which is interesting because that must mean that there could be some bugs and fixes and bug fixes respectively that do not affect business value, which means that probably they shouldn't be fixed. But there are obviously bugs that should be fixed because without fixing them, we will lose business value that has already been delivered in the past. So essentially, working on bugs and fixing them is a sort of risk management exercise where you have risk of losing profits or risk of losing customers and so on, and you're managing it by making sure that your software works well and keeps working. Then the third type of work that we have in software engineering is technical maintenance. This means upgrading your libraries, your platforms. This means making sure that you don't have vulnerabilities, and this means making sure that your software is in general modern and uses modern features. Because, for example, if you have a mobile application over time, the UX and UI that you're using probably will become less modern, and so you might actually just lose customers because you didn't you weren't up to date with that. So all of these, they are maintenance tasks, and they also, for the major part, you would not consider that they ship extra business value. Instead, they retain existing actualized business value. Then there is a work type of work number 4. I'll call it big rewrite. So this is something that is besides the scope of just normal refactoring that you do while you're working on some one of the other items. It's when you actually need to change something so drastically that you need extra project or extra work item to register it in your system. So this, I call these big rewrites. They can be with or without shipped expected business value. So it's always a question, okay, if we do this rewrite, what we're gonna get as a business out of it? And usual argument by people who initiate such a rewrite, which usually are developers or some architects, etc., is that there will be some extra benefits that will gain long term, such as, you know, code is easier to change, or we have more maintainability or something else. Why I say that it can be without a shipped expected business value is because just like features, you can also have somebody think that something needs to be rewritten, but they actually cannot actually tell you what is going to be better after it's rewritten. It's just how they feel. So expected business value of big rewrites is usually very large, which is very interesting about this topic. However, the shipped expected business value is harder to attain. What I mean by this is that the big rewrites often fail, in the sense that a lot of work, development work, gets put into them, and the rewritten code base or rewritten module does not see light of day, because either it took too long, project got cancelled, or it did not reach feature parity, so it was released, but it did not actually replace the previous module, so you have to maintain 2, and so on. These kind of things are risks with such rewrites, and this is why shipped expected business value is usually lower than expected business value, and sometimes even significantly. It depends on the size of the rewrite. And finally, because of these topics, the actualized business value is even lower, because very often you believe that certain approach to rewrite will make things much, much better. So there is first hurdle to overcome is that you need to ship the rewrite successfully, so that has chance of failure. And then second hurdle to overcome is that in actuality, even if it was shipped successfully, the benefits might be not as high as you expected. So actualized business value here is even less probable. And final type of work item is research. So it's some kind of investigation or exploratory charter, something that is supposed to give the organization or team the information to make a better decision, be it a technical decision or maybe some kind of business decision. This can also be with or without shipped expected business value. Question to the group. Is there anything missing? Some kind of work item that I haven't included? Huh? I put it on research. Explore your work. Mm-hmm. No, good. Thank you for mentioning. Anything else? Hmm? Communication. So communication and alignment. Yeah, I get that. So thank you for feedback. I will include this. That makes sense. Because I basically assumed this is part of, because why would, so you can think about it as a separate task, or you can think about this as a part of any of these, because yeah, but why do we do Scrum, communication, or etc., so we can deliver these things? Well, it's type of work, but it's if you didn't have to do any of these 5, you wouldn't need to communicate, right? So it's like kind of like a dependency of other work items. But I think it's important to include, because there must be also communication meeting or collaboration meetings that don't have any value as well, sometimes, right? So there are definitely the ones that are valuable, but sometimes there are probably the ones that are not valuable. So that's important. Okay, so in terms of shipped expected business value, let's review what these companies look like in general. So how does 0.1x delivery look like? Well, first of all, in such a system, or in such a software engineering organization, software engineers will spend only exactly 95 to 98, somewhere in between percent of their time working on work items that do not have expected business value. So nobody knows what it's about, nobody cares. There's probably some ticket slinging going around. Tickets just go left and right. People implement whatever. They rarely ship something, so very often there is some kind of work and it gets either stuck or doesn't go through code review and just gets lost. And also they work hard to retain existing actualized business value. Usually the organizations like this are quite old and they already have a system that's already delivering a lot of business value. So there is, besides the work to implement new things, there is a lot of work to retain existing business value. In this particular case, what does it actually mean? Well, it means that there is a lot of work on bugs. There are technical rewrites left and right. There's maintenance work because that has to be done. There are features that are political, so they do not have really expected business value. Their value is that they satisfy some stakeholder that is just inside the organization, so it's not real value. And also, another challenge is where there is ongoing projects and they get cancelled in the middle. So that means that developers worked on something that might have actually had expected business value, but they never got delivered because projects got cancelled. So it's a wasted time. So in general, when you think about these numbers, you would understand that roughly 1 out of 140 work items actually gets manifested and shipped expected business value. And why this happens? Because the organization, the software engineering organization in these companies, what you would call has grinded to a stop, because most of the work that they do is either a waste or it's a work to retain existing business value, which is risk management. So it's very hard to deliver new stuff here or improve things. For example, so there is I'm not gonna say any names of the companies because that would be not nice. But there is a company that I know of. I have a couple of friends working there. They're not happy, obviously. So why would they be? And it's a large, profitable business, and software engineering is operating at 0.1x. Most of the work that they do is they're fixing bugs. Lots of bugs. So it's like they basically start every day with new bugs and they have to fix them. There are things that the organization know of that will bring real business value, that has a lot of potential, but everybody is afraid to touch it. I'm not even talking about development teams themselves, but everybody, all stakeholders. So business stakeholders and project managers, they think that they can't fathom to achieve that. So they're afraid to even open that topic. Well, that organization did like a huge move from monolith to microservices. It took them, I think, something around 1 year to do this. And then 1 year later, they decided to move from microservices back to monolith. So because they realized that microservices did not work for them. That was it, basically. Yeah, so it's essentially a lot of waste time, and if you calculate everything, it would be roughly 0.1x. The things aren't moving, business is just maintaining what is already working. And because it's profitable, it has like a good margin, it is surviving, so it keeps operating. I'm sure if their margin starts dropping, they'll either not survive or they'll have to change something here drastically. But because it works for the business. A second case study, which is it's also a profitable business, but instead of having a very large engineering team, it has a very tiny engineering team because the business isn't software first. It was like just a normal business, and software was on the side. But it became slowly a core of the business because it became very important. The software engineering team, of course, that they hired was the cheapest one, so they were not very experienced, mostly like junior mid levels. And the code base grew large over last 6 years with a very tiny team. By tiny team, I mean 4 people at maximum at all times, and sometimes like 3, sometimes 4. So it's really tiny team for 6 years. They got to the point where feature development is very hard and very slow. It's almost impossible. So sometimes, as a business stakeholder or CEO of the company, they come to the team and ask, "Hey, could you implement this feature?" And they would just say, "No, we can't," because and it's true, they can't. And of course, at some point, about 2 years ago, they said, "Well," this developer said, "Well, the big rewrite. If we rewrite this whole thing, we'll be able to actually develop features." 1 year later, they do the rewrite, but the development in the new code base is as slow and as difficult, if not slower, because they didn't know what they did wrong in the first instance. So what was their chance to fix their problems again? There was a very low chance of success. And finally, they did not completely replace the old code base, so there was no feature parity. So instead, they ended up maintaining both code bases. And of course, that made development is even harder. Moreover, in this whole process, half of the team got burned out, so they quit. Yeah, 2 people left. Yeah, my other friend joined later, and when he opened the how the engine looks under the hood, he was really surprised. Yeah. Do you have a question? You were raising the hand. I think somebody was raising their hand. Okay, no, it's good. All right. So that's another example of the company like this. So how does that was 0.1x? That was sort of a rare case scenario that wasn't very frequent. So this 1x delivery, would be your average company. How does it look like usually? Well, now engineers spend 80% of their time working on items that don't have expected business value. Or among this 80% would also be time for maintenance work and bug fixes to retain existing actualized business value. So there isn't much work that is done with intent to attain new expected business value. Practically, this is not as bad as 0.1x group. So for example, you probably don't have here the political features yet. There's still too much bug fixing and maintenance work, and maybe there's a rare rewrite or 2. All in all, you would have 1 out of 5 features on average that have expected business value, and probably around 70-80% of them actually get shipped to production. So actually go through the whole process and get in the hands of customers. And what happens to the rest of effort? Well, it's still quite a large waste. And when I say waste, I mean when developers spend time or some other people spend time, and it's wasted. It did not produce any value in the end of the day. But this is what you would call an average software engineering organization these days. And obviously, we can do better. So a case study, it's one of the companies that I also know about. It's a mid-sized startup, so like 200 people total, operating at 1x. So what do they have? So some teams actually work on almost exclusively on valuable features. Some teams work on not so valuable features, or they don't even care. They don't know about what does it mean. They just implement features. There is an okay cross-functional collaboration between team members most of the time. There is a large code base because the company existed for a while, and the quality is actually average to good. So it's not horrible to work with. It's possible to work with. There is good test coverage, etc. And most of the things that they work on actually get into production. Now, there are still problems in systems like this. There's still very long lead time to delivery. People still juggle multiple work in progress items, for example, open pull requests for weeks, and there is also too much rework. So they don't just do work once, they have to do the work, then figure out that something is wrong, they have to rework, then they also have to maintain their work that is in progress. There's too much rework. Well, an occasional big rewrite because we always are striving to find a way to make things better, and the obvious answer is always a rewrite. I mean, it sounds like I'm talking. My talk is about rewrites, but it actually isn't. But it's just that every time there's a problem, I see the rewrite is one of the causes, but not the only one, of course. So what does 5 weeks delivery look like? And why did you decide not to do animation this time? Okay, well, software engineers spend only 20% of their time working on work items that don't have expected business value or retain actualized business value. In an organization like this, the bug work is actually quite rare. And the reason for this is because there is probably higher test coverage and features, and generally I have good regression test suites and so on. And the changes that they do work on and the new features do have clear business value at their core, so people are thinking in terms of business value. All in all, you would see that 4 units out of 5 have expected business value, and they manifest in shipped expected business value 90% of the time, which means that they get to production in the hands of customers. So this is quite good. It's a nice organization to work in. And sometimes, very often, things get realized into actualized business value. And for that, usually the product, engineering, and business need to come together, and I make sure that I identify a good customer pain point to solve, and that they solve it. And now we go through animations. That wasn't my fault. I think it's something with the presentation tool. All right. Oh, well, you see the whole thing again. So then I don't have, by the way, example for 5X organization. It was actually an organization I worked at. There was 5X before, and now we're much closer to that, to 10X. So it'll be after that slide. So software engineers spend only 2% of their time on work that retains actualized business value, so like bugs and maintenance work, and they don't spend a minute on anything that has no expected business value. So expected business value is essentially a requirement to start any work. All in all, you would see 98 out of 100 units of work that have expected business value, and 98% of that work will get delivered to production to the customers. Engineers themselves are also 1.5x more effective in their work, and the reason for this is because they don't only have mastery of software engineering, they also have mastery of collaboration. It's a very important topic because to attain very complex, to solve very complex problems and big problems, you can't just solve them on your own usually, so you need collaboration. And so if collaboration is not very effective, that would slow down the delivery. Which means that if you have engineers who are good at software and good at collaboration, then you have higher speed of delivery, a higher quality. So these numbers can vary, by the way, a bit. So for example, one number can be 97, another 98, 99, and so on. But essentially, if you calculate this and compare it to 1x organizations, you'll get 10x, roughly. And we go through the animation. All right. So case study. This is This is a company I'm working at. It's at the moment 9.5x under this math when I calculated. 10% of the time is spent to retain actualized business value right now. We're trying to reduce that. This is one of our goals. So obviously 90% of the time, the other 90 is spent on features that have expected business value. This is always a discussion between engineers and product management and a business. What kind of business value are we delivering? Because if engineer does not understand, they will not even start working on that. Then the failure rate to ship to production is only 1% or less. So that means that it's very easy to get things in production. The reason for this is because we get things in production multiple times a day. And all in all, when you calculate all that, you'll see that 90 units out of 100 will have expected business value, and 99% of the time they are manifest and shipped expected business value. And the software engineers are at that level of high efficiency because they mastered engineering and collaboration. The final number is 9.5x, and we don't have big rewrites. That's something that we do differently. No big rewrites. We just refactor and improve code. Well, so how do you actually become 10x software engineering organization like this? How do you make sure that you focus so much on business value and not enough on things that don't have business value? Well, there are 2 ways to do this. You can either do it from scratch. So if you're founding a new company, that's easy. That's why I did. I joined as a first employee, and I got to build the whole thing, the whole system. That's easy. So let's talk about this. So this is my case. So first engineer, or CTO, or whoever, tech lead, has experienced an environment like this before, and that was true for me. I have experienced this before my consulting days. You start with core values and principles, so you need to know what kind of principles and core values you need to put into the system before you even start. So that's sort of, you don't need a lot of them, but this is an important decision to make because all the decisions you'll make later need to rely on these. You need to care about not only about technology. You do need to care about technology, obviously, but not only. You also need to care a lot about business value, and you need to think in terms of the whole system. So the whole business is basically a system that delivers value to the customer, and of course gets profits from that. And you need to think about this as a whole. And then you essentially, as you grow, you put the necessary practices in place. So for example, if you start from scratch and you're one engineer and maybe you have second engineer, you shouldn't like put the whole system of everything in place, because when you do, it will be just an overhead. So you'll be slower and it will not work. So it's essentially put things that are needed at the moment, and then as you grow, there will be more things needed, there will be more problems that you encounter, and you will need to find solutions for them. Another thing to do when you start from scratch is that you probably want to hire slowly, because your organization, your software engineering organization size will be small, and you cannot afford to double, because what happens when you double, you will likely to violate core values and principles, because you'll get people on your team who don't share them, or potentially don't share them, and don't share them exactly, and they'll overwhelm you with numbers. So it's important to hire slowly, so you can sort of assimilate people into this culture. And what is important is either previous experience working in similar way, or people who are excited to work in this way, who are excited about business value, about fast delivery of value, high quality. And then there is another challenge that as the organization is growing, you will encounter, is that sometimes you would have a challenge where a problem, where an obvious solution would be to step back and degrade one of your core values and principles into what everybody else does, so to speak. And we'll be tempted to do this because that will solve the problem, but it will introduce much more problems down the line, the long-term issues. So instead, instead of this compromise, what you need to do is innovate. So you have to think harder. How can we, instead of stepping back, step forward and find a even better way to solve this problem? And of course, let's go through the animation. Extreme difficulty is for existing organizations. Oh, why is that? Well, if you're an existing organization, you already have, 10, 20, 100 teams that are working in a certain way. And if let's say if you're starting from 1x organization, an average organization, you'll have a difficult time to get it higher, but not impossible. If you start from 0.1x, it will be even more difficult because you'll need to first make your way to 1x. But if you had to do this, how you would actually do this? Well, first of all, the organization should believe that this can be done in the first place. And what does it mean, that organization? Well, at least the person who is a top technical leader in your organization, CTO or CDO or CIO, needs to have experienced that this is possible. So they had needed to have worked in an organization where a lot of business value was delivered and the delivery was fast and high quality. Because if there is no belief like this, then there's probably nothing can be done, because the changes that are required are very drastic. Then what you need to do, you need to find people who either experienced the 10x software engineering or extreme programming, design thinking, lean startup, and other environments, and you need to inject them into every team that you have. And you need to aim for a ratio of 30%, because essentially the people who you are hiring here, they'll be sort of like change agents, because they'll need to change how the organization works. And there will be, of course, resistance to change, because existing processes and existing systems might overwhelm them. So you need enough of these people so that they have fighting chance. Then you need to start with values and principles, of course, first. And you either need to convert people into these values and principles over time, and people who cannot be converted and don't want to work this way and don't care, you need to replace. The same about the bottlenecks and value chain, thinking about the whole business instead of just thinking about your team or your small department or your small microservice. This kind of thinking needs to be trained for the personnel, so people who are at the individual contributor level, and also the leaders and middle management needs to be trained into this type of thinking. You would need to revamp hiring because most likely the situation as it is right now was created by a hiring process that wasn't quite working. It wasn't hiring for the right things. So you would need to go back and see how you're hiring, what is the process, what are you looking for. And essentially, if you want to move from 1x to 10x, you need to look for different things. And finally, you'll need to flatten the structure, at least temporarily. That is important because the most difficult part in organizational change is the middle management exists to essentially freeze processes in place, make sure that they work as they are. So if you want to change something in how organization works, they'll be the obstacle. You can flatten the structure in different ways. You can make them, you can make less structure and make them also do the individual work, or they can move up, or they can go out of the organization, or it can go to like another business unit or something. So there are ways to do this. There is a third way, which is combination of the two. It's a sort of compromise. It's still challenging to do. It's not easy, but essentially you can combine these two approaches, existing organization and from scratch, into one. And you do this by creating an entirely new business unit or even a separate legal entity. Then you grow it like a startup, so like a new company like we discussed before, when you can do this from scratch into a larger organization. Then what you do is that you slowly transfer responsibility. So you take small cats off the organization and transfer them into the new one. And then you are able to essentially grow that next software engineering organization while shrinking the legacy one. So it's similar to what we do when we strangle the beast in software. That's similar approach to organizations. I've seen this happen twice, where a big organization built like a lab, and then the lab outgrew its development capacity in terms of software engineering. Yeah, so what is 10x software engineering delivery system? I told you that I wrote a book about it. So first, as I told you, it's about values and principles. So I start at the core with the values. They are sort of softly, fuzzily defined. They are qualities that give us edge to attain the 10x delivery. Then on top of these values, there is a set of principles that's built. They're based on the values, and they're different from values because values, they're sort of, you know, you can ask one person about their value, they'll have their own opinion, another person, they'll have a different opinion. But principles, they're different because they're sort of harder rules that realize the qualities from the values, but they are sort of rules you can tell if somebody follows it or not, in a pretty Boolean way. And finally, what you do is you build practices on top of these principles. Usually one practice would follow 2, 3, or 4 different principles. And practices you can either build from scratch, if you can't find something that already exists in the industry, or you look at what is there in the industry and you pick the practice that follows your principles that you want. So the values. Let's start from the first one. The most important one is valuable outcomes. As you might have realized, the whole presentation was about business value and customer value. So this is at one of the first, the core value is to care about valuable outcomes. Everything that we do should be delivering value. Then another one is frequency. Frequency is an interesting value because with higher frequency, you would notice more problems and earlier that you can solve to improve your delivery. Feedback, because you want to know if what you're doing is working, and this is on different levels. This is on levels of feedback with your customers, then you know if you're delivering value or not, and if you need to change. What? No? You know if you need to change anything or not. And then collaboration, this one is important because, as I told you, when you're trying to solve large or very complex problems, you can't solve them on your own. So you need to collaborate with others. So you need to to bring multiple people with different specialties, different skills together to solve very complex problems. However, also there's another approach why collaboration is important, why I put it at a force value, is because when you're a professional, like for example software engineer, then you master your skills to a certain level, and it becomes harder and harder to become even better. So it's like you need to invest much more time to become 1 or 2% or 5% better. Interesting enough that at this stage, if you then start practicing collaboration skills, they're easy to improve, because if you focused always on software engineering side, then when you start focusing on soft skills and collaboration, they're easy to improve because they were at the low to medium level, and to get them to high level is still easy, and you can do it quite quickly. But by doing that, now you suddenly are much better in collaborating with others, so it will increase your efficiency not by 5% or 10%, but by leaps and bounds, sometimes by 100 and 200%. Then the value of speed. Obviously, if you want to get to 10x software delivery, you need to go fast. However, on the other hand, you have value of quality, because if you go fast and you just deliver lots of stuff, you might sacrifice quality. So the quality serves here as a sort of balancing value. You want to make sure that you also are delivering good quality to the customer, but you also your system is high quality, so it's easy to work with, so you do not lose any other values long term. Then another very important value is value of courage, because you don't want to be stuck because you're afraid to do something. So if you think that you need to perform a production release, you should be able to perform it. If you think that you need to question a business stakeholder on whether something is valuable or not, you should be able to do this. This is also a very important value. Simplicity is very important, because the whole system, the more complex it is, the harder it will be to develop new features and deliver new business value in it. So that's why it's important to always try to make things simpler and simpler and simpler as much as you can. And the final value to close it off is integrity. So integrity is very important, because when you have a system that works, so if you have all these values and you have principles and practices that make it all tech, what you have is a very powerful engine that can deliver lots of shipped value. So if you don't have integrity on top of that, you can deliver something that's not really good for society, for example. So it's important to have integrity from this perspective of ethics, because if you have a very powerful tool, you need to have moral and ethics to wield it correctly. But there's another reason that integrity is here, is because sometimes in business it makes sense to take a shortcut, for example, and for example, get more valuable outcomes at higher speed to sacrifice some quality, right? So sometimes you have to do this because of reasons. And then when you have strong value of integrity, what you do, you took a shortcut, and then after the changes are shipped and customers are happy, you take some time to restore your integrity. So you restore the integrity of quality. So it's also a balance in value to make sure that the system is coherent over time. These values, they have relations between each other. For example, you have, I'm going to give you the examples. So values of speed and courage, they enhance each other, they sort of multiply. And value of quality, it balances out the values of speed and courage, because if you're too fast and you're too courageous, you can become reckless. And if you add quality on top of that, then you can balance it out. Of course, I would love this presentation to last for another 45 minutes, but it will not, because I have 44 principles and 59 practices to show you. So instead, I will look at 2 examples only, 2 examples of practices. So first practice is business value filter. Obviously, it's based on core value of valuable outcomes. It follows the principles: refuse work with unclear business value, and treat any statement of value as a hypothesis. And the way it works is that as a software engineer, you need to take on the responsibility to be the last line of defense of making sure that no work item that goes into actually in progress or gets planned goes without expected business value. So what does it mean practically? Practically means that if you have some kind of planning meeting, the business stakeholder or product manager presents you some work item, you look at it and it becomes unclear to you, so why are we doing this? And then you need to ask that question. You need to ask why are we doing this? What's the value? You need to ask it until you understand. At some point, You'll either understand it because it has some kind of value behind it, or you will understand that whoever brought this item to the planning session does not know themselves why they're doing this, or have no good explanation why is it important. So in this case, you need to reject that work. So you need to really say, hey, we can't work on this. This doesn't have business value. So of course, there is more work to do after that. You need to collaborate to find business value or change the item until it's valuable. But still, it's important to have this point of rejection. And second practice is called restless and continuous refactoring. It's based on 3 different values of quality, speed, and simplicity. It follows 3 different principles: continuous improvement, restless elimination of sources of slow. By slow, I mean slow in terms of work and process, and always be reducing complexity. So the practice itself is to keep the refactoring work as integral part of any other value delivery. So whether you're working on a new feature, or you changing existing functionality, or you're fixing a bug, the refactoring should just be an integral part of that work. It's not something that is separate, doesn't need a separate approval process, doesn't need a ticket. And you apply it restlessly. You sort of, refactoring becomes autopilot activity. It's the same as writing code. So you have an idea, you write the code. You don't ask somebody, what can I write this code or not? The same thing here, refactoring. You don't ask whether you can do a refactoring or not. You also do not look who is the original author of this code. It does not matter. Why it does not matter? Because you should be happy if somebody made your code better. That's one thing. The second thing is because this needs to be done in a spirit of teams, code ownership, and stewardship. What I mean by this? I mean that single person should not own a module. The whole team, or even the whole organization, should own all the modules. That's what stewardship is. Of course, sometimes some people will be responsible for a module, but it's okay for other developers to contribute without feeling afraid and without having to double think if they need to refactor on this. So this marks the end of my presentation. If you want to learn all the 9 values, 44 principles, and 32 individual practices and 27 team practices, you can read my book. And this book is it introduces this and builds this framework for that stems from these values, goes through these principles, it goes through these practices, but it also gives you a tool to build your own practices when you need to adapt to something. Do you have any questions?